So we learn about acid-base reactions and gas evolution reactions in detail. Acid-base reactions in solution. Different scientists have given us different definitions of acids and bases. These are known as acid-base theories. We have 3 of those, but for this chapter, we'll start with Arrhenius definitions. There are 2 more, and then we'll learn them in later chapters. According to Arrhenius theory, acid is a substance that produces H plus when dissolved in water, and base is a substance that produces OH minus when dissolved in water. So acid is a proton donor in aqueous solutions, and base is a hydroxide ion donor in aqueous solutions. Okay, so any acid when dissolved in water produces protons, and when any base dissolved in water produces hydroxide ion. Again, remember, these are just Arrhenius definitions of acids and bases. Okay, now there are some acids, like for example H2SO4. Okay, and this contains more than one ionizable proton. It contains 2 protons, right? So this is a diprotic acid. This is a diprotic acid. So there are some acids that produce more than one proton. Okay, so this is known as a diprotic. There could be a triprotic acid as well, right? Okay. Okay, now when the acid donates the H plus to water, what happens to it? First of all, what happens is that it forms a hydronium ion with water. So the H plus will form a hydronium ion with water. So when H plus is present in solution, it won't float around. It forms H3O plus with water. So any strong acid will contain H3O plus in water. Most chemists use H plus and H3O plus interchangeably, because it is believed that H plus will right away combine with water to produce hydronium ion. So number of H plus ions will be equal to number of H3O plus, because as and when H plus is released, it combines with water to form hydronium ion. Now bases will give out OH minus ions, and bases, some weak bases like ammonia, and I'll tell you how to remember weak and strong acids and bases. But some weak bases like ammonia, if you think about it, there's no way ammonia can produce OH minus. So what happens is they do not contain OH minus. So when they react with water, what they will do is they will extract a proton from water to become an ammonium ion, and what is left over of water is OH minus. And so this is how ammonia, a weak base, produces OH minus in water. Okay. So what's happening in an acid-base reaction? The H plus, now go back and remember your precipitation reactions. You moved or you separated the solutions or the aqueous solutions into cations and anions. You essentially do the same thing here. H plus and Cl minus present in acid, Na plus and OH minus present in acid will produce water. So that's this combination of positive and negative ion, and NaCl, that's this combination of positive and negative ion. Okay, now if the salt that is produced as a result of acid-base neutralization, if it is soluble, so H plus Cl minus, all of them aqueous ions, plus sodium plus and chloride ions, again aqueous ions, produce H2O. And remember, we said, this is OH minus. And remember, we said if the salt that is produced, if it is soluble, then we write it as Na plus and Cl minus, right? So this is the acid component, this is the base component. Water is produced as a combination of H plus and OH minus ion, and sodium ion attracts chloride ion to form sodium chloride. But sodium chloride is soluble, so we write it as sodium plus and chloride minus. Remember, these are spectator ions. So what's the net ionic equation for an acid-base reaction? If both the acid and base are strong enough, then the net ionic equation is the formation of water for strong acid, strong base reaction. Okay, now what are strong acids and what are strong bases? These are all strong acids. Hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric. These are all strong acids. Anything that is not strong is weak acid. For the purposes of your class, anything that is not strong is a weak acid. So nitrous is a weak acid. Okay, nitrous acid is a weak acid because it's not a part of this table of strong acids right here. Okay, now group 1 hydroxides, strong acids. Some of group 2 hydroxides, strong bases and strong bases. Ammonia is a weak base. So your job for this class, again, when we talk about pKa's in 1212, we'll decide on how to decide which is strong acid and strong base. But before that, for the purpose of 1211, these are strong acids and these are strong bases. And how will you write a reaction for acid and base? Given an acid and base, one of the product is water, that is coming from 1 mole of H and 1 mole of OH minus. Okay, and then I'll discuss this more further in acid-base titrations. And another salt is formed. Based on whether that salt is soluble or not soluble, we write the net ionic equation.